Hey everybody, welcome to Bill Sky, the assembly guy, and what we're going to do in this video today is we're going to show you how to move data into and out of an ARM processor's registers. Now we did this for x86-64, now it's ARM's turn, and if you haven't looked at the ARM video I did on registers or allocating memory, you might want to go back and check those out. I've got links to them in the description of this video. But let's get started. So I've got my Linux up here and running. Let's go ahead and create a project. I'm going to create a 64-bit project. And you always want to make sure you pick the ARM project. Let's give it a good name. All right, let's go ahead and open it up. All right, good. I've got the newer one. It's got the data section in it. That's cool. And let's organize things a little bit. Okay, so now we've got our project set up. So with the project all set up, let's go ahead and first of all, let's create some statements that will move literals. So I'll put a comment here, move some literals or immediate values into our registers. And the way that you do that is very simple. You use the move statement, just like on x86-64. I'm going to move, I'm going to put it into x0, and then we put a hashtag. The hashtag said this is going to be an immediate value, and I'm going to put the decimal value 100 in there. So move the decimal value 100 into x0. Now let's move a hexadecimal. And the way that you do that, let's put that in x1. Do the hashtag again, but this time you put a 0x in front and then 100. Move the hexadecimal value 100 into x1. And let's go ahead and build and make sure everything's cool. All right, looks good. And let's debug it. Let's take a quick look. Now, you can never get too much practice debugging. So I'm going to open a terminal in my folder. I'm going to say make debug1. I'm going to open up another terminal, make debug2. There's my code. Let's go ahead and step through the first few statements that are the statements that display the welcome. Now, when I step through the SVC, as we've seen in other debugging demonstrations, not only is it going to execute the SVC, the interrupt to the operating system, but it's also going to execute the next line, which is this move x64, which is decimal 100, move that into x0. So let's watch x0 as we step through. It has a decimal value of 100. So if we look back at our code, where are we on our code? We're in this line of code right here, line 21. We moved 100 into x0, and you can see in the debugger 100 or hexadecimal 64, which is the hexadecimal value of 100. Now let's go ahead and move the hexadecimal value of 100 into x1. And you can see in x1 we now have the hexadecimal value of 100 in there. So that's how you move literal values into the registers. Now you can also do the same thing into the W registers on 64-bit. If you're on 32-bit, you're going to want to use the R registers, but the statements are pretty much the same. So let's go ahead and continue. Quit our debugger, which is very important, and now we're back in our source code. So what else do we want to do? Well, I want to move some register values into other registers. That's very simple too. You use the move statement, and I'm going to say move into x3 from x0, move into x4 from x1. Very, very simple. So I'm going to save and build that. Okay, I'm going to move it down here so we can see our code. I'm going to start my debug 1. I'm going to start my debug 2, run through the code that we've already tested. Now we're going to move x0 into x3. Now x0 has hexadecimal 64 in it. So does x3. x4 x1 has hexadecimal 100. Now so does x4. So we went ahead and we moved data between the registers. If you want to do 32-bit data, use the W registers. If you're in a 32-bit program, you use the R registers. So let's continue and let's quit. And now let's talk about variables. Let's go into the data section. Let's create our first variable. Now, if you don't remember how to do this, like I said earlier, I went ahead and put a link to the allocating memory and ARM processors video that I did earlier, as well as the registers, so go back and take a look at those. But let's create our first variable, dword var. It's going to be a double word, and I'm going to give it the value 4, 5, 6, 7, 8. So to put something into that variable, let's save and build that to make sure I didn't do something wrong. I do a lot of builds, and the reason is because when I type a line of code, if I'm not really sure about the line of code, and actually today I do, these days I do it, it's just habit, and it really eliminates the possibilities of where my error is, as opposed to writing 100 lines of code and then building it. Oh my God, then you don't know where, you wrote all that code. Okay, so let's go ahead and put a new section down here, move some data from variables into our registers. Now, there's a two-part process to do this. Number one, you have to move the address of the variable into a register. And the second step is dereference that register and put that data into a register. Now, for those of you that might be a little bit iffy about dereferencing means take the register that contains an address and go out to memory and grab the data at that address. That's pretty much what dereferencing means. Anybody that's coded in C or C++ should know this. If you don't, you can probably find some additional information, but that's what it means. It means there's an address in a register, dereference it, which means take that address, go get the data, and stick it in the destination. So that's the first thing we're going to do. So we're going to do number one. So we're going to move, or actually we're not going to use move, we're going to use load register. So load register into X3 the address of dword var. So that's going to put the address of dword var into X3. Now we're going to load register X0 the dereference, to use the square brackets of X3. So that will dereference the address that's in X3, go out to memory, grab that data, and put it in X0. So let's build it. Looks good. Let's go ahead and put this over here on the side so we can see it. I'm going to start my debugger, and I'm going to go ahead and just step through a bunch of this stuff. Okay. So here is our load R, our load register into X3, and notice it has the 0x4000F8. That's the actual address of our dword var variable. So let's go ahead and step, and you can see the address is now in X3. Now we're going to say load into register 0 the dereferenced value found at the address that X3 contains, and you can see our big long number. So that's how you move the data into the register. Now let's do some experimentation here. Instead of doing that, what if I did this? What if I said move? Oh, I'm in the wrong spot. What if I said load into X0 the dereferenced dword var? Will that work? Well, let's go ahead and build it. You might think it would work, but it doesn't. ARM wants you to put the address in a register and then go get it. And that's really kind of what x86-64 does. I don't know for sure if that's exactly what it does, but there's some mechanism in the other processors that kind of do the same thing. So that just won't work. So that's an error. So that's how you get data out of a variable and put it into a register. Now, what if we had just a word here? So if I said word var dot word, and let's put zero x AABBCCDD, how would I put that into a 64-bit register? Well, let's go ahead and build that first. Build fine. So I would pretty much do the same thing, except this time what I would do is I would say load the register X3 with the address of word var, and then I would say load W0, the address of X found in X3, because we want to move a 32-bit value into there. So let's go ahead and build and make it. Looks good. Oh, what did I do wrong? I forgot a comma right there. I love making mistakes because everybody does. Okay, let's go ahead and debug that guy. So let's run it. Okay, so let's start step through. Okay, there's our big number. Now, what we're going to do is we're going to load into X3 the address of our word var, and then we're going to load into W0 the dereferenced X3, which is our word var, and you can see the AABBCCDD. So let's continue. Let's quit our debugger, and let's go back to our code. And that's it. That's how you move data out of a variable into a register in ARM. But what if you have something smaller? What if you have like a byte that you want to move into a register? What we've been dealing with here are the large data, right? But what if you're dealing with characters? How do you move a single byte, let's say? So I'm going to go back up here to my code, and I'm going to say byte var dot byte, and I'm going to give it a value of A. Let's save and build that. Okay, we created our byte correctly. Now, you can do this. It's not a problem at all, but one of the things that you have to worry about is when you're moving things smaller than a word into registers in 64-bit, you can't move them into the 64-bit registers, which would be X0, X1, and X2. You have to move them into the W registers, which are the 32-bit registers. So what we're going to do here is we're going to say load into X3 the address of byte var, and then we're going to say load a register byte. So we're going to load a single byte into W0 dereferenced X3. So that's going to load a single byte from that memory location into X0. Let's go, actually, no, into W0. Oop, I almost made a mistake. So we put the address into X3, and we move the value dereferenced X3 into W0. Now, why didn't we put the address of the byte var into X3? Because in a 64-bit operating system, or a 64-bit ARM processor, the addresses are 64 bits in size. So you must use, for the address, you must use a 64-bit register. So let's make that. We'll go ahead and put our code down here. Let's debug it. Let's debug it. Okay, so let's get down to that code with our steps. All right, so there we go. So this is our load the register into X3. This is going to load our, actually, no, that's not it. Let's go down some more. There it is. So this is the one that's going to load our byte value into X3, not the value, but the address of our byte var. And then we're going to be loading a single byte from that memory location into W0. Now take a look at our X0. And there's that single character. Hexadecimal 41 is the capital letter A. It has a decimal value of 5. So that's how you load a single byte. Let's continue and let's quit. What if it's a signed byte? Let's say instead of the letter A, and let's go ahead and put an S byte var. And we're going to say byte. And we're going to say -10. So let's put the value -10 into our S byte var. Let's go ahead and build it. Now, how do you move a signed byte? So I'm just going to copy this. And let's put some commas before I forget. Move a byte into X0. Move a word into X3. Or no, I'm sorry, that's X0. Even though it says W0, you're still moving it into X0. And let's move the signed byte into X0. Now, it's very, very simple. I'm going to change my variable name to S byte. And instead of LDRB, we're going to say LDRSB. So that is a signed byte. Now you're going to see a big difference here. Because remember, when you have a signed byte, the most significant bit is a 1. And that bit has to be copied to all the upper bits in a larger register. So you're going to see that register get filled with bits. So let's build that. Let's debug it. Let's move our code down here. And let's get going. Let's get down to that location. I'm going to show you how to set a breakpoint on the next debugging. Okay, so we're going to put the address of our signed byte into X3 right here. We're going to dereference X3 and put it in W. Now watch X0 up there. It's got all those F's in it. And that's because it took that bit and it moved it all the way to the left. And because W0 is a 32-bit, it filled it up 32 bits. So it extended the sign. It's like move SX. It extended the sign. Okay, let's continue and quit our debugger. And let's take a look at a couple of other ways of moving that data, moving signed and unsigned, larger values into our registers. So if you've got something a little bit bigger than a byte, like let's say you have a half or a word or a word, let's create a couple of variables. So I'm going to say hword var, or just, hword var, hword plus 100. I don't even need the 100 there. Let's put 999. So how can we do that? Well, I can say load register X3 equals hword var. And then we use the LDRH into W0 X3. Same thing if it's signed, you would use the LDRSH into W0 X3. So that's for signed, or this is for unsigned, and this is for signed. Anything smaller than a word, you have to use these LDRS statements. Anything larger, you just use LDR. So let's go ahead and debug this real quick. Let's build it. Looks good. Now I'm going to show you a way so you don't get caught up in trying to figure out are you at the right line or not in the debugger. So let's move this code down here. So what we're going to do in the debugger this time is we're going to create a breakpoint. And what I'm going to do is I'm going to move I'm going to scroll down here using my mouse scroll bar. And I want to put a breakpoint at this location right here. So the way that you do that is you say B for break, and you say asterisk 0x, and you type in that number there. It's 4000F4. Let's do 4000EC, 4000EC. And now you see a breakpoint there. So what I'm going to do is I'm just going to type continue, and now execution has jumped to that breakpoint. So I'm going to load into X3 the address of our signed byte. There's our signed byte. We did that earlier. Now I'm going to move into X3 the address of our hword var. We're going to move that into W0. There's our 999. If you remember in our code, we saw 999 there. And now let's do it as a sign movement. And it's the same thing because the most significant bit of 999 in binary is not on. So 0 is pushed all the way forward. Okay, now let's go the other way. Let's put data back in to a variable from the CPU. So what I'm going to do is I'm going to come up here and I'm going to create a variable. Let's create a quad word variable. I'm going to say, or a double word variable, dword var2 dot dword, and let's just put 0 in there. Let's scroll down and let's put some data back into that variable. So we're not going to use LDRB, we're going to use STR. Or LDR, we're going to use STR. So let's, first of all, again, you have to put the register of the variable you're going to be moving it to into x3. So I'm going to say, or any register, x3 equals dword. Let's put in a var2. So that's, oh, I got to put an equal sign there. So that's going to put the address of dword var2 into x3. And now let's say str into dereferenced x3. Oh, I think I did that wrong. Let's put x0 into dereferenced x3. Now this is a little bit confusing because normally the destination is on the left, but for the str statement, it actually is on the right. So the destination goes to the dereferenced x3. So it's going to put whatever is in x0 into x3, or into the dereferenced x3. So let's go ahead and save and build that. Let's start the debug. All right, so I'm going to get into the code. Let's jump down to where our code is located that we want to stop, and that's at address 400100. So I'm going to put a breakpoint with the asterisk 0x400100. All right, let's continue to jump down to that code, and we're going to load into x3 the address of our dword var2. And now we're going to store that into the dereferenced dword var2 address. Now, before we do that, let's look at that memory location. Now, GDB, unbelievable debugger, but it's a little bit cryptic. So I'm going to display, and that's what X does, I'm going to display one hexadecimal 8-byte. G stands for 8 bytes, starting at address dword var2, and we can see it's all zeros. If I want to display that as a decimal, I would use D instead of X, and it's a 0. So let's step. So now we stored the value that was in X0 into the dereferenced X3. Let's go ahead and look at it in hexadecimal again. It's 3E7. Let's look at it in decimal. And there's our 999. And if you look at our X0, it was definitely 999. So that's how we move the data from the register into memory. So let's continue with our debugger. Let's quit it and go back to our code. Okay, so now let's take something smaller than a double word or a word, 8 bytes or 4 bytes. Let's say we've got a byte that we want to move into memory. Now, that is the same thing as we did with load. So LDRB will load memory into a register. STRB will load a register, a single byte from that register, dereferenced from to X3. So whatever address is in X3, the address of the variable we want to move the data into, we take a byte using SDRB from X0 and stick that in X3, or the dereferenced X3. And I love this error. It even gave me an idea. Should I have used the W? Yep, I made a mistake. I'm supposed to only use W values. I'm only supposed to use the W registers to do these moves to something smaller than a word. And there you go. What if it's signed? Well, there is no such thing as an STR-SB. Let's put that in there and take a look at what happens. And it basically says, I don't know what STR-SB is. That's because it's assumed that the register already has a signed byte in it. All of the bits have already been set on that need to be set on. So they don't even have that, so you don't even need it. What if you have a half a word? So you'll say STRH. Remember, we have to use a 32-bit register when we're dealing with something smaller than a word. And then that one works. And again, there is no STRSH because it is assumed that you have all of the 2's complement already set up when you go from a register to memory. The only time you need that signed or that half, that signed byte or that signed half, is that if you have a smaller value in memory, The most significant bit is 1. You're putting into something larger. You need to move all those bits over, is when you're going from memory to a register. And so you can go through the debugger, try that out, and see how that works out for you. So that is how you move data into the registers of the ARM CPU and back out to memory. Hope to see you at the next video.